Now, this is still something that we talked about in class, but I wanted to go over it a little bit more carefully here because this is a pretty important topic for this investigation, and that's the idea of a density curve. So the density curve is going to be this graph, and it doesn't have to like connect the dots of all the bars here, but it's supposed to give you the general shape of how the heights of the bars are going to be. And there's going to be a few different words that we could use to describe them. And I pretty much guarantee you're going to be asked about these words in some way on your next exam. So the first one is unimodal, and unimodal is where your graph only has one high point on the graph here. Whereas bimodal, you have these two different peak points here. There's one peak point and a second peak point, and those are the bimodal. I mean, technically, you could have a trimodal, but we don't ever talk about that. We just deal with unimodal or bimodal. That's pretty much it for us. The other two things that we have are, it could be skewed to the left. Now, remember, it seems like it should be right because it's more on the right side, but the skew is the idea. You say, okay, where's your high point? So like right around here. Look how much is to the right. There's a little bit to the right, and there's a lot more to the left. And because of that, that's why it's a left skewed graph. Whereas over here, here's where your high point is. You have a little bit to the left, but you have a much longer thing to the right, which is why it's going to be skewed to the right. So I've seen a lot of students get these confused and switch them. And the thing is, when you have, look at our exam questions, if you give me the wrong one, you don't really get partial credit on that, right? So make sure you understand the difference between these two things. Lastly, we can talk about things that are roughly symmetric. And what that means is, if you look at the high points, there's about the same amount to the left and right of it. That's roughly symmetric. And the last one is symmetric, and it's what's called a bell curve. And it's called a bell curve because if you look at this kind of shape here, that's kind of the top of a bell, right? If you ring a bell. And so it's called bell-shaped. It turns out this is going to be a very, very common shape that we're going to see, but it's important that we at least know what the words are. And we're going to give a math name to this. The math name is normal distribution. What that means is it means your graph is symmetric and bell-shaped. So that's what normal distribution is talking about. Now, if it's perfectly bell-shaped, then it's normal distribution. If it's not perfect, but it's close, we don't say normal, we say approximately normal. Now, there isn't that big of a difference for us. Pretty much every scenario is going to be approximately normal. It's going to be very difficult to be perfectly normal, so it doesn't really matter that much for us. The two things that we're going to care about on these types of distributions is something called the mean and the standard deviation. So let me try to explain here. The mean, that's your middle high point right here. That's what your mean is going to be. And if you want to measure, in some sense, how spread out it is, it's going to be measured by the standard deviation. And that is what we're using. This weird symbol here is called sigma. So this is the lowercase Greek letter called sigma. This right here is the lowercase Greek symbol called mu. And for whatever reason, we like to use Greek letters here, so that's what we're going to be using for these. Now, we're going to compare these three different ways of talking about average. Now, again, when you say the word average, most people would think you mean the mean, which is you add up all the data points and you divide by how many there are. But in math, average is not really well defined. Average could mean the mean, it could mean the median, or it could mean the mode. And there are different real world scenarios where you'd want to use each one of them. Now you can see on these box plots over here, this line right here, as we talked about before, that is always the median line. And this little dot here, that is the mean. So I could foresee a question on your exam that says, for the yellow graph, is the mean or median bigger? And in that case, the median is going to be bigger. The mean is to the left of the median, so therefore the mean is smaller. And so things like that are what we want you to be able to do. We want you to look at a graph and interpret what it's trying to tell you. Okay, so we'll stop here and pick up on the next one.